Good day, children. Today we are on to our next lesson. This is all about the properties of exponents and how different exponents, when you do something with them, are going to be changed. All right. Let's say that I had 7 times 7 times 7 times 7. Right? We would say that this is 7 to the power of 4. Yes? 7 to the power of 4 is 7 times 7 times 7 times 7. We should all be well aware of that by now. But if I were to use something like the associative property, which means I can group together different aspects and my math problem will be the same. And I were to say, all right, well, what if I had 7 times 7 times 7 times 7? Well, this would be 7 to the power of 3 times 7 to the power of 1, but that still is 7 to the power of 4. I still have 4 7s I'm multiplying together here. Okay, well, what if I had 7 times 7 times 7 times 7? Well, that would be 7 to the power of 2 times 7 to the power of 2. But since I still have 4 7s here, this would still be 7 to the power of 4. All of these are all the same thing. They all are going to equal the same thing. And so that's going to get us started into the 3 different properties we're going to be talking about today. All right, so 3 different properties we are talking about today. One of those properties we're going to deal with, get rid of this really quick. We're going to deal with multiplying powers with the same base. So one thing we're going to talk about is multiplying powers with the same base. We're going to be talking about dividing powers with the same base. And last we're going to talk about is raising a power to a power. Whoops. Raising a power to a power. Those are the 3 things we're talking about today. Multiplying powers with the same base, dividing powers with the same base, and then raising a power to a power. All right. So if you're taking notes, here are the 3 things you need to know, and then we're going to break them all down one by one. So with multiplying powers, if we have something to the power of m times the same base to a different power, this is the same thing as b to the power of m plus n. So if we are multiplying powers with the same base, we add up the exponents to get our final answer here. The base stays the same the whole time, and we add up our exponents. Multiplying, we're going to add our exponents. With dividing, b to the power of m divided by b to the power of n, we're going to do the opposite. We're going to do b to the power of m minus n. And so this would be our answer when we're dividing. As long as the base is the same, if we're dividing, we subtract those exponents. And then finally, raising a power to a power. If we have b to the power of m, and we want to raise that to the power of n, we want to raise a an exponent to a power, we would write that as b to the power of m times n. So we would multiply those two powers together, and that would be how we solve that. All right, I just gave you a lot of information. I gave you some things that could get confusing, so let's talk about each one of these, break them down a little bit more in depth, starting with multiplying. And this we said was bm times bn equals bm plus n. This is our formula for what it might look like. All right. So I'm seeing that. If I say, all right, I have 5 to the power of 4 times 5 to the power of 3. Okay, so here's bases are the same. I have two 5s. One base is being raised to the power of 4. One is raised to the power of 3. So this first one I would write as 5 times 5 times 5 times 5. Then I'm doing this, and I'm timesing this all by 5 times 5 times 5. Right? I have 4 5s here, times by 3 5s here. But since this is just repeated multiplication, and I have a lot of 5s, I have 1, 2, 3, 4, 5, 6, 7 5s. This would end up being 5 to the power of 7. Now, if you look back up here, this would be 5 times 4 plus 3, and 4 plus 3 is 7. So our answer, both answers would get us to 5 to the power of 7. So that's why this multiplication works. It works as long as base is the same, it works to be adding these up. Okay, what if I had something like, what if I had something like 16 times 16 to the power of negative 7. 16 times 16 to the power of negative 7. Well, 16 by itself, anything by itself like this, what it doesn't have a power, is always raised to the power of 1. Okay, so we know our base is now going to be 16, and we know our math problem is going to be 1 plus negative 7. 1 plus negative 7, we all know, is negative 6. Yes, you're all right. So our answer would be 16 to the power of negative 6. That's how multiplying. Multiplying with the same base, you add up your exponents. What about when we are dividing? With the same base. Dividing with the same base, we said b to the power of m divided by b to the power of n equals b to the power of m minus n. We said this here was our rule. So let's check it and see how this works for us. All right. If I have 6 to the power of 9 divided by 6 to the power of 4, that is the same thing, right? Remember, division is just like saying fractions, right? So this is just like saying 6 to the power of 9 over 6 to the power of 4. And if I mathed that out, I would get 6 times 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 6. I think that's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 on top, and 6 times 6 times 6 times 6. 4 on bottom. When I'm dividing, and I have the same thing on top and bottom, those simplify and cancel each other out. 6 and 6 cancel each other out. 6 and 6 cancel each other out. 6 and 6 cancel each other out. And 6 and 6 cancel each other out, leaving me, all that's left is right here, which happens to be 6 to the power of 5. And if we look back at our original equation, 9 minus 4, right, we would have gotten 6 to the power of 9 minus 4. 9 minus 4 is 5. 6 to the power of 5. When we divide with the same base, we subtract our exponents. When we multiply with the same base, we add our exponents. Divide by the same base, subtract our exponents. And finally, let's talk about raising a power to a power. Raising a power to a power. Let's give us some new colors here. Swap some things out. Big old nice gold. How about a galaxy? Wonderful. All right. So let's say I had 4 to the power of 3 squared. Or 4 to the power of 3 times 4 to the power of 3. So I would write that, and I would say, all right, well, this is 4 times 4 times 4 times 4 times 4 times 4. Or 4, 1, 2, 3, 4, 5, 6 times. 4, 6 times. If I were to do it the math way and say 4, 3 to the power of 2 equals 4, 3 times 2. 3 times 2 is 6. I still get 4 to the power of 6. As long as we are following these 3 rules, right? As long as we've written down these 3 rules, right, children? We always write down all of the things we take notes on. As long as I've written down these 3 rules and I can use them, I should know how to multiply with the same base, divide with the same base, and raise a power to a power. All right. If you need to watch this again, watch this again. I will see you all tomorrow.